Hey folks, I wanted to show you guys something. I thought that this was probably of interest to some folks. This is my chimney, and I just wanted to show you this because you're not going to see much coming out of it. And you know what I do see is basically clear. You can see a little bit of a heat ripple, but in the air, and you can't really see much else. That's it. That's what you get. Of course, along with some chemtrails. I don't know. What do you think's more concerning? The chemtrails here, or what's coming out of my chimney? You know what I'm saying? All right, so I'm gonna take you for a little walk here, and take a jump over, and show you guys what we got here. Okay, can you see that? Right at the peak there of the burn zone, 550 degrees Fahrenheit, almost 300 degrees centigrade. Now let me see. I'm gonna open this door up and show you. Okay, fire is going, but no smoke being produced. I contribute that in part to the fire brick that I installed in this, because this is, this is old school. There's nothing new about this. Well, here's my modifications. Okay. Now into this this boot that I made. Okay, we dip down, and inside of here I've got a coil of copper, and the water comes in. I got two check valves. I got a temperature and pressure sensor right here, and you can see the current temperature of the water at this stem is about 100 degrees. Okay, and when this raises, okay, I've got a temperature sending unit right here that I duct taped on there. It's actually mated up against that pipe. So just like that pipe, mated up against it, and I've got fiberglass thread, or whatever you would call that, and I wrapped it around there tight to the post, and the wire comes up along the pecs. Okay, cut a hole here to access. I got two elbows up there, pecs elbows, and then up along here I've got clamps that hold this to the header. Okay, now I bring this, runs along the header here, and I've got another access hole that I cut in order to run all these lines. It actually goes through the wall here into the garage where there's another header, and then runs in to my utility room here. And what we got here is a temperature controller and a relay unit, okay, for the pump. Okay, now for the temperature sending unit, I set this here. As you see, the temperature's dropping because the pump is running, and the cooler water should be cooling that copper coil down, and that pipe will reflect that temperature change. Now once this hits 120 degrees, you'll see the the zone light shut off. That's the red light. You see it dropping down here. Takes it a minute or so for this to go. It depends on the temperature of the water, how fast it cools. It's getting there. There we go. Okay, so it shuts off at 120, and it'll turn back on at 133 degrees. It takes a little while for the heat to build up to that point, but what happens is the heat will get to that point and the pump will kick on and it will cool back down, and this is how I'm heating the hot water in the house. Okay, so you can see I wired all this myself. Let's see, it goes from this circuit protector, runs into the relay box, which in turn has a 24-volt transformer in it, which powers the electronic temperature control, and that relay, once switched, goes to this here outlet, and I have a power switch for the whole unit, and that will shut off this box. Okay, and now this cord runs down. I've got a 3-speed pump. Okay, and that runs behind the furnace. Okay, from the cold water, or cool water I should say, out of the hot water heater. Okay, and the hot water return, after it comes out of the copper coil in the potbelly stove, comes into the top of the hot water heater, and the thermodynamic nature of hot water forces the cold water down towards the bottom, so you're constantly getting a cooler water flow from the bottom into the boiler, and out of the top you get your hot water. So, and while I've been sitting here talking to you, the temperature has already gone up, as you can see, and turned on the cycle again. The water sending unit, usually because the hot water is going to be pretty hot in there, it will raise before it lowers. And that's about it. That's how we're doing the hot water here at home. Now obviously this is something that we would want to do post collapse, or any type of collapse of the system. We do it because basically it saves money. I mean, the amount of money we spend on propane, I mean, it's just ridiculous. And this is completely running minus the electrical, because you do need electricity to run the pump. It's completely running off the grid. I mean, if it ever came down to it and the electrical was out, I could run a generator to run this, or some sort of battery array, or solar or wind turbine. So, and you know, that is actually something I'd like to do at some point, but it is very cost prohibitive at some point, so down the line. And we're working on getting everything, you know, our food stored up, and we know what's coming, folks. You better prepare. If you're not used to showering in cold water, well, this might just be a solution for you, because it's no fun, let me tell you. I tried it, and I couldn't last more than 30 seconds under that cold water. I had to boil some water before and take a sponge bath, and that was when we ran out of propane back in December. I've worked on this for, it took me a couple weeks, reading up on what I wanted to do, designing the system, and putting it all together. I've never sweated a pipe in my life until now. I think I did a pretty good job. Not a single leak. So there's some parts where you see that's a threaded connection. Temperature and pressure release valve. And that'll evacuate into the floor drain here. And no, I didn't really prepare for this video, so excuse the mess. Kind of did this on the fly. Have a good one, folks. Thanks for watching, and please rate and comment below.